Hi everyone, this is a socket coding on Mac platforms. Let me first explain how the program can work. I'm going to give you a demo. The client and server programs in two different protocols, UDP and TCP. The code that you can see here, that is the UDP server program using a function. So on this function, all the procedures of what the UDP server needs to be configured. It uses, because this is a UDP server, the socket is created for the family of sock DRAM. And then that socket needs to bind the IP address and port number. This is a port number that this server needs to open. This is the IP address of the client that you want to receive. If we have only the blank, then this UDP server wants to receive from any server. And then print the statements here to see whether the UDP server is ready. This server continues. First, the server socket needs to receive, and then this receive from function returns the message and address. This address is a tuple format of the IP and port numbers about the client. So that message first needs to decode. When any messages needs to send out, then needs to encode. And when the message receives and to display render, then we need to decode it. So decode, and then we can take a look. The message itself, and then first element of that address, that is IP address, and the port number. The second item in this address is port number. The first we want to say we received it, the messages. And then if we want to, then we can reply back to the client. Only we change the message to uppercase. All right. And then we send. We means the socket itself send out. This function is called by sending the port number. So UDP server is now open and bind of this IP and port number. Therefore, the client program needs to use the same port. The client uses the same socket, because if it is a UDP communication, then UDP socket for server, UDP socket for client. And we want to do while loop. So say the variable stop initially false. If it is not false, of course it is not, because stop is false. If we say not stop means that is true. So while true, so initially it's true. And then this client needs to talk to the server first. So write a message to server, or type, if stop means it's quit. Okay. If it is a stop, then we need to change this stop variable to true. Therefore, it doesn't go into the else statements. If it is not stop, then we need to user input needs to be encoded and send. Encode and send. Send where? This send to from the socket, client socket, needs the data, and the second element here, second parameter, needs to be the address and port number. So local host and port number. Okay. So send out. And then wait if this guy receives any. Okay. So client socket waits any message from the server. So receive from returns the message itself and the server information. So server has two elemental in tuple, as we looked at on the server side. Server has the address here, that is the client address. At the client side, server means, yeah, this address is a server address. So the first element in this server is a server IP, and the second element is a server or port number, and this is the data. So when a client receives data from the server, then it needs to decode to read. Okay. All right. So how I can demonstrate this? We need to start with the client. From the Windows, client can be, oops. Okay. So holding down command button and hit spacebar. There, if we put terminal, the terminal comes up. Okay. At least you need to have one terminal for server and one or more terminals from the client. So open up the server, and then there is a shell menu. There you need to create new windows for basic. So let's say this is a server program, server. This is a server. This terminal is a server, and this terminal is a client. Okay. I want to put this side by side. All right. So where is the location for this? Get the copy path and come here. This is file itself, so we need to go to that. So change directory to that place. Same thing for on the other terminal. And there is also the location. This location that we the server needs to first ready to serve, right? Server program here, Python UDP server. I'm using function and then py, and then as you can see here, UDP server is ready to serve. That is what this, right? And this UDP server now waits to receive data from the client. So we need to start the client. Python, same thing, UDP client func.py, and it says write a message. So I can say hello UDP server, and then at the server side, server received hello UDP server from 127.0.0.1 colon 51110. This is a server port. Okay. At the server side, server doesn't do anything here, and it sent back to the client. Here, 3 less than sign, and then what is it? Processed by UDP server. Hello UDP server. The message originally sent from client is not all uppercase, but it went to the server and replied from server. It changed to all uppercase. That is here, right? Message changed to uppercase. And that's from 127.0.0.1, and port number, this is a server port. Server opened what port? 53535. This is a server port, and this is a client port. And client still say it works well, and it goes to, it says the server received, it works well from the client, and immediately it returned back to the client. So client immediately received less than triple less than sign, and then processed on UDP server. It works well in all uppercase from this port. This is server port. Okay, this continues until this guy says stop. If I say stop here, then it stopped, right? At the server side, this guy does not know. This guy still waits, right? So what we can do, at the TCP side, I improved this a little bit, so you may be able to see it. But server stopped. I mean, the client stopped. Server is still waiting, right? So if I redo this, then server still waits, and then you can say hello again. Then it says hello again. At this time, the client port number is not the same as before, right? This is right. So it came back, and if I say stop, it stops at the client side, but server still runs on, right? Because we didn't do anything here. In this case, we need to interrupt it, right? Control and C. Control and C, that is the interruptions. So interrupt, that way it stops. So now both are stopped, right? So I want to clear this terminal. Clear, then it clear the terminals. Okay. Now we move to the TCP. TCP server in function, definition and function call, and TCP client function definition and function call. First, TCP server. Server received the port, and then the socket needs to be defined. We call it S, and then that socket binds. Again, it opens from any IP, but this server socket bind it to my port number. What port number? The server port number, 20560. Okay, and then this server listen, and when there is a request from the client, TCP client, and accept it. As it accepts, connection is established. So connection, and then there is a client address. In the earlier UDP case, we say that is only address, And then we split it, the first element and second element as we need. But in this case, as we receive, we receive it separately. That's fine, right? Either way, this is another technique. So we receive the connection. This is a client IP. This is a client port number. And then we write it here, now connected. And then we have a while loop. While loop continues. And then this connection, now connection, right? Not the socket itself. This connection, because TCP is a connection based. Connection receives RCV, which is not the same as the UDP. UDP, socket itself, receive. The language is not the same, right? Not RCV, but RCV from. That is the case of UDP. This is case of RCV is case of TCP. Connection itself needs to receive from that port. And then that is the data. We need to decode it to display. So we decode it and display here the print statements. First, if there is no data, which means client does not send, then we can say, hey, bye, and then break. And if server communicate to the client, this is a mutual interaction. This is another example, right? UDP case, server simply change the client message to uppercase and ship it out. But UDP case, TCP case, in this example, we ask server to enter. There's another input function. So that will be the reply. So reply and the message from the client itself together. And it says the server reply to whatever the client message, colon. This is a server reply. All together encode and send it to the TCP client. TCP client, same thing. It needs to create a socket in the same family, sock stream, like server, TCP server, sock stream. And then connect. Remember, the TCP is a connection based. So when TCP client needs to connect, it uses IP address and port number. Port number, that is the same port number that TCP server opened and bind. So use that. And then while loop, like the other, the client side of UDP, we set up the variable stop and initially false. This is another case. Stay alive and initially is set to 1. 1 means true, 0 means false. So this is another technique that I demonstrate. And while stay alive, and then the client write something or say stop to quit. If it is a stop, then this stay alive equals 0. So it'll stop. This client will stop. Otherwise, client send the message by encoding it. As it sends out, and client now wait some reply from server. Okay, and S means this is a socket, right? And then when data comes from the server, and then print it. Okay, so we'll demonstrate it here. Now we'll do the same thing, same as we do, but It should be TCP server. So I am start the server first. Yeah, the server is waits. It's not yet connected, right? It connects only the client wants to connect. So TCP client. So when I launch client, then then server recognize it and then connection message. Yeah. Oops. What happens? This is not started. Python TCP server funked up. Oh yeah, it was not started. Right now my eyes, it's not. My vision is so weak. I didn't wear my glasses, so I'm not able to see it. Okay, the client. Okay, client. Now this server seems to run. There's no error messages, and still wait if any client comes here. So now this is a client program. As we hit this, then this guy says, okay, connected by, this is a client, still on the same local host, 52027. This is the port number of this client. Okay, and this client, server is waits any message from the client. So we can say here at the client side, hello TCP server. And then here received from a client, what client? So local and this port. Hello TCP server, right? And then we can say, how are you, client 52027, right? 52027. And it says received from that, reply from TCP server. That is how are you, client that port number. This is how you can practice. All right.